Hello everyone, my name is Ivan and this is a nuclear war simulator. The goal of this project is to create an interactive tool that you can use to visualize large-scale nuclear conflicts and to make it as realistic as possible in order to raise awareness about the dangers that nuclear weapons present to our society. With this tool you can visualize conflicts with hundreds and thousands of warheads and calculate the impact on the population. There are several maps available in this simulation. First, there is this realistic view of the planet that you can see here. Then there is OpenStreetMaps, which is very similar to Google Maps, where you can zoom in, where you can find your city and where you can find your street. In addition to this, there is a population density map. The population is represented by the colors green and yellow. Yellow means a very high population density. So, if there is an explosion happening somewhere, let's say over Paris, it will have an effect on the population. And as you can see now, there are almost no survivors left in the center of Paris. And we can visualize the casualties as colors red and blue. In the center of Paris, most casualties will be from blast and heat. And in this elongated area that you can see here, the casualties will be from radiation from fallout. If you want to set up a new conflict scenario, you can start by designing the forces. First, you can design a warhead by setting the yield and the fission fraction. Then you can design a missile and put your warhead on this missile. Then you can put some missiles on a carrier, in this case a submarine. And here you have the choice between ballistic missiles, cruise missiles and gravity bombs, which will behave differently. Then you can place the units on the map. Let's start by placing a group of launch control centers and silos. If we click on the map, the units will be distributed and will behave as a wing. In addition to this, we can place submarine bases with submarines, bomber bases with bombers, and mobile units. The next step is to generate attack plans. Let's say we have selected some Russian units and we want to design an attack plan for them. Here you see that we have selected several silos with ICBMs and several warheads per ICBM. The green and red line represents the maximum range of this missile. Now let's distribute these warheads on American silos and population centers. After assigning the first warhead, our maximum range is limited to this area due to the mirroring process. And now we can distribute the remaining warheads on the silos and launch control centers. After doing that, we can distribute some warheads on a population center, in this case Denver, and we can use the population density for guidance. If you think this process is too tedious, it can also be automated. After placing the units and generating the attack plans, you can save the scenario, share it with other people, and tell your story of the conflict. Let's say in this case the conflict starts with an escalation in the Black Sea, to which NATO reacts by sending bombers from European bases, leading to a wider escalation on the European continent, and provoking a reaction from the United States, which then leads to an uncontrolled escalation worldwide. The scenario that you can see here is nowhere near accurate, but instead serves as a demonstration of the technical capabilities of this simulation. Humanitarian consequences from hundreds of explosions can be calculated within seconds, and you can directly visualize them. In this case, there are almost 50 million casualties in the United States, 40 million casualties in Russia, and 11 million casualties in Germany. In addition to the short-term effects of nuclear explosions, the amount of smoke from burning cities is calculated, and nuclear winter can be visualized in an understandable fashion. If you are interested in this project, please visit my website to stay updated, and I'm always looking forward to your feedback. Thank you for your attention.